China has built an electric car that is not powered by a massive battery bolted underneath the floor. The car is powered by the floor itself, the partitions, and the core structure holding the entire machine together. And the craziest part is, it charges so fast that you pull up, plug in, and before you have even finished checking the notifications on your phone, your car is ready to drive again. Over 600 miles of range, ready to go. That is not a concept model sitting behind glass at a tech show. That is a real vehicle on sale right now. And the company that built it did not start as a car maker. They started in a cramped rented room, specializing in making batteries for mobile phones. That origin story is not just interesting. It is the entire reason why they were able to pull off something the rest of the car world once declared was impossible. Done. If you have ever felt frustrated by long charging stops, worried about running out of battery mid-journey, or wondered whether electric cars are actually ready for real life, then what you are about to hear will change everything. We are going to dive into exactly how this happened, why the number China put on stage in early 2025 made the entire global auto industry fall silent, and the real secret helping them take over the entire global EV industry. If you find videos like this useful, hit the like button right now. It only takes half a second, but it genuinely helps this channel more than you think. And subscribe so you do not miss what is coming next, because this is just the beginning of the story. Let us get into it. To understand why this technology is such a massive turning point, you have to understand where this empire came from. Because this story does not start in Silicon Valley or in some famous engineering lab in Germany. It starts in 1995 in a small rented room in Shenzhen with a plan to produce rechargeable batteries for mobile phones. At the time, mobile phones were exploding in popularity, and someone had to create the batteries inside them. They saw that gap and went straight for it. They grew by learning how to make high-quality batteries at a price that nobody else could match. And in the process of doing that, they became deeply, obsessively excellent at understanding exactly what makes a battery work and what makes it fail. They studied every material layer, every chemical reaction, every weak point. That knowledge did not disappear when they moved into the automotive field. When Chinese conglomerates entered the car business in the early 2000s, they did not think the way car companies still think. They thought like a battery company that just happened to be building a vehicle around their battery cells. That difference sounds small, but it is actually enormous. Traditional automakers treat the battery as a component they buy from the outside and then design the car around it. China treated the battery as the heart of everything, the thing they understood better than anyone else in the room. By 2020, that mindset led them to make a bet the entire industry deemed reckless. They chose to build their future around a battery chemistry called lithium iron phosphate, LFP, a material that most competitors had quietly abandoned. The reason everyone else left it behind was simple. It could not store as much energy as newer chemistries. It was considered the weaker, cheaper option, the thing you use when you cannot afford something better. But they saw something different. They saw a chemistry that was naturally safer, had a longer lifespan, and could be produced at a lower cost. And instead of accepting its energy limits, they decided to redesign the entire battery cell from scratch. They made the battery cells long and flat like actual blades, and packed them tightly together without any wasted space. No bulky module casings, no redundant protective boxes around the battery clusters. Just clean, dense, flat energy storage laid out as efficiently as possible. After that, they did something theatrical to prove it was safe. They drove a fully loaded 46-ton truck straight over a battery pack. The battery pack did not catch fire. It did not leak. It barely even dented. The goal was to completely erase the phrase spontaneous combustion from discussions about electric vehicles. That kind of confidence only comes when you build the thing yourself and deeply understand every component that makes it up. But that battery was just an initial breakthrough. It was still a separate box. The next leap, the one that would flip the entire blueprint upside down, was still a few years away. And to understand why it was so important, you first have to be honest about what is broken with the electric cars rolling on the roads today. The electric vehicles that most people can actually buy right now are generally very impressive in some respects, but they also come with a series of frustrations that marketing campaigns tend to cover up. Let's start with charging time. The ads say fast charging. The reality at most public stations is that it takes you 30 to 40 minutes to get a meaningful amount of battery. That is not a quick pit stop. That is the time it takes for a meal, a long phone call, or a chapter in a book. For those who grew up with the habit of spending 5 minutes at a gas station and then driving away, that burden is a real friction point. It changes how you plan your trips. It adds a layer of psychological baggage that gas cars simply do not have. Then there is the operating range. Most affordable EV models today offer a range of 250 to 300 miles on a full charge. And that is in ideal conditions. Take that same car into a harsh winter and the operating range can drop by up to 30% or more. Cold temperatures slow down the chemical processes inside the battery, and the car has to burn energy just to keep the battery sufficiently warm. Cold weather also attacks charging speeds. You can pull into a fast charging station in January and watch it deliver energy at a fraction of the speed it could achieve in August. But here is the part that rarely appears in the commercials. In almost every electric vehicle on the market today, the battery is a heavy, separate box strapped beneath the undercarriage. It does exactly one job: storing energy, and it contributes nothing to the vehicle's structure. Engineers have to build the entire car around it. The battery is there first, and everything else must adjust to it. That layout leaves real consequences. The battery box adds weight that brings no benefit to the car's rigidity or safety. The heavier the car, the more energy it needs to move itself, which means you need an even larger battery pack. It is a vicious cycle that constantly works against itself. Chinese engineers looked at all of these problems and decided that simply improving the current design bit by bit was not enough. The design itself had to change. Starting with a question no one had ever seriously asked. What if the battery and the car were the same thing? The idea sounds impossible until you hear the logic behind it, and then it sounds almost obvious. What if you didn't build a separate battery box at all? What if the battery cells themselves became a structural part of the car, doing two jobs at once? Storing energy and physically holding the vehicle together. That is exactly cell-to-body technology. Instead of placing a battery box under the chassis, the top surface of the battery cells becomes the actual floor of the passenger cabin. You are not sitting on top of a battery pack. You are sitting on the battery itself. The cells are part of the car's skeleton, distributing force throughout the chassis just like steel beams do in a building. Think of it this way. The old approach is like strapping a heavy backpack to the belly of the car. The new approach is much more like the bones in your body. Your skeleton doesn't just sit inside you doing nothing. It supports you, absorbs impact forces, and makes every movement possible. This design makes the car about 70% more rigid than previous approaches. The increase in efficiency is equally important because they eliminated the outer casing of the battery box. About 76% of the total space inside the system is now actual energy storing cells. Stripping away the excess layers means the same physical footprint now holds spectacularly more energy. That is why the range numbers have pushed past the 600-mile mark. Lighter weight means higher efficiency. Higher efficiency means a longer operating range. And because the battery is now part of the structure, the car handles better, too. All of that is extraordinary in its own right, but none of it is the number that forced the whole room into silence. That part comes right next. 5 minutes. That is all. Using a charger that supplies 1,500 kilowatts of electricity, roughly 40 times more powerful than a standard home charger, The new system can go from near empty to over 2/3 capacity in the time it takes you to use the restroom and grab a snack. Those 5 minutes add about 400 kilometers of driving range. That is about 250 miles from a single stop. Let that sink in for a second. 250 miles. 5 minutes. That is not a top-up charge. That is a charge for the entire trip. Now let's talk about winter. At minus 30 degrees Celsius, charging from 20% to 97% takes only about 3 minutes longer than it does at room temperature. 3 minutes. Not 30, not 50. 3 extra minutes in the absolute worst cold most people will ever experience. This system circumvents the weather problem through thermal management integrated right into the cell-to-body structure. A fast car with a fast battery is only useful if there are places to actually charge it. A 1,500 kilowatts charger is not something you just plug into a standard power line. Pulling all that power at once from thousands of stations would put a colossal strain on the electrical grid. They solved it in a way that is almost surprisingly simple. Each of these flash charging stations has its own energy storage system. The station slowly and steadily draws power from the grid throughout the day at a rate the grid can comfortably handle. When your car pulls in, the station dumps all of that stored energy into your battery at maximum speed without ever causing a spike in the grid's load. More than 4,000 of these charging stations were built before the technology was even sold to the public. The target is 20,000 stations by the end of 2026. The chicken and egg problem doesn't apply here because they are building both sides simultaneously, selling over 4 million cars a year. And that exact same core technology runs across all of them. This platform scales directly to trucks, buses, and delivery vehicles. So what does this actually mean for you? It means the conversation about electric vehicles has just changed. When 5-minute charging exists on a real car you can buy, 30-minute charging starts to feel like today's dial-up internet connection. The 3 biggest reasons people hesitate to switch to electric vehicles have always been charging time, range, and reliability in cold weather. The new system solves all 3 issues at once. 5 minutes to charge eliminates the time argument. Over 600 miles of range eliminates the distance argument. 3 extra minutes in minus 30-degree cold eliminates the weather argument. And that is the big picture. A company that started by making phone batteries in a small rented room has just redefined what an electric car is, driving the global takeover of an entire nation. Not by building a bigger battery, but by turning the battery into the car itself. If this video gave you something to think about, hit the like button before you leave. Takes 1 second and truly makes a difference for this channel. Subscribe and turn on notifications so you can watch the next video as soon as possible. And leave me a comment with your honest answer. If there was a 5-minute flash charging station near your house right now, would that finally convince you to switch to an electric car? I read every comment and I want to know what you really think. See you all in the next video.